Let's get started. I would like to introduce to you KYZEN's process engineer, Wayne Raney.
Thanks, Sherry. Today we're going to be talking about automated concentration monitoring and control when cleaning metal parts in your parts washer. To start off, there's 3 different modes of operation for chemistry concentration control in a parts washer. From the most labor-intensive to the least labor-intensive are manual measurement with manual chemistry additions, manual measurement with automatic chemistry additions, and automatic measurement with automatic chemistry additions. So let's talk about manual measurement with manual chemistry additions. The most common method of manual measurement is by use of a conductivity meter. We offer it in kits. Here's the kit with the calibration solutions. To use this kit, it's as simple as taking a sample of your wash bath, inserting a probe, and reading the conductivity, which is displayed in the units of Siemens. Once you get the conductivity reading, you'll locate this on the y-axis, follow it over to the line, and see what the concentration reads on the x-axis. The second most useful method of concentration measurement is titration. Here you'll need a sample of the wash bath, an indicator, and a titrant. The basic principle is that you'll add the color indicator to the volume of your wash bath sample, plus a little bit of water. Then you'll add drops of titrant until the fluid changes color. You'll keep track of the number of titrant drops used and correlate it to concentration by way of a chart or multiplying it by the factor. This procedure is found in the technical supplements. The least acceptable method is a refractive index. Due to the influence of oils and coolants in your industrial parts washer, this is the least preferable method of measurement. So specifically, after you measure the concentration manually by the way of either conductivity or titration, you'll have to manually add chemistry. This is a manual measurement and manual chemistry additions. After you add the chemistry to boost up your concentration, you'll have to check the concentration again. So here's where conductivity or titration once again comes into play. This is manual measurement and manual chemistry addition. It's very labor intensive. Next, we'll talk about manual measurements and automatic additions. This is where the KYZEN Chemtroller comes into play. It's basically an automatic water-powered proportioner pump. Here's a couple pictures of the Chemtroller mounted on a stand above a drum of chemistry. The basic premise is that when your washer drops in fluid level, it will trigger a solenoid valve to open up to allow more water to fill the tank. So instead of filling the tank, it'll power the proportioner pump, which will draw chemistry into it and add water and chemistry into the wash tank. This particular customer is using a chemistry called Metalnox M6324CP. It has built-in corrosion protection, so their application needs this chemistry in the wash and the rinse. So that in this situation, we installed 2 Chemtrollers, one on the wash and one on the rinse. Each Chemtroller is utilizing a different concentration setting. Even though this automatic dosing system is automatic, it still needs operator interaction. So there is a certain amount of drift associated with the setting. So this is where the operator once again has to check the concentration by way of conductivity or titration. When first implementing the process, I suggest checking the concentration at least twice per shift until you get the handle on changing the knob position, how it affects the concentration in the wash tank. The Chemtroller only adds chemistry and water when the washer calls for makeup fluid. So in order to allow the Chemtroller to change the concentration after changing the knob position, then you must allow the machine to make several additions. I suggest only changing the proportion of chemistry to water only once every 4 hours, but I highly suggest checking the concentration twice as frequently. This will allow you to get a feel for how fast or how slowly the Chemtroller changes the concentration. KYZEN offers different ranges of Chemtroller proportioners. Here's a guide on how many revolutions the dial relates to the percent concentration it'll add to your wash bath. Remember, these are approximates, but it'll give you a good starting point. Once it's dialed in, then you'll have trouble-free and accurate conditions. So far, we've covered manual measurement with manual chemistry additions, and we have touched a little bit on manual measurement with automatic chemistry additions. The most preferred method of concentration control in a wash bath is automating measurements with automatic chemistry additions. The main instrument that KYZEN uses for this is the conductivity control system, or CCS. This system uses a conductivity meter to measure the conductivity of the wash bath, and a metering pump to make the necessary additions of chemistry to get the concentration to the set point value. When concentration, as read by this conductivity meter and probe, goes lower than the set point, the CCS will automatically add chemistry by way of the metering pump to the wash tank until the conductivity reaches the target value. The conductivity meter will read the actual conductivity and convert this to a 4 to 20 milliamp signal. It outputs this to the metering pump. The pump compares the current value of the set point, which is preset internally at KYZEN before shipment. It's important to note that the CCS only adds chemistry and that water additions should be made automatically by the washer. This is an illustration of the KYZEN CCS and how it's connected to the parts washer. Notice the conductivity probe is tied into the wash pump's fluid flow. The parts washer and the CCS function as independent systems. The only communication between them is an optional signal to the metering pump to indicate the main wash pump or mixing pump is energized. The CCS cannot detect the fluid level in the wash tank, and the washer doesn't know that it has a CCS connected to it. It's strongly recommended to use this pump signal for indication so that the CCS only functions when the wash bath is mixed, and the probe can get a good reading. This also reduces the risk of adding chemistry to an overfilled tank. This is what the CCS looks like when the metering pump and the conductivity are married together in the CCS and connected to the parts washer. In this example, the customer has opted for a traditional install using a stand, which provides the metering pump and conductivity meter above the drum of chemistry. You can't see it, but there's an optional drum level alarm attached to the system. This drum level alarm is a system designed to alert the operators of a drum low condition and a drum empty condition. A yellow light will indicate when the drum is low, and a red light with an audible alarm will indicate when the drum is empty. This helps reduce the need for operators to have to continuously monitor the chemistry level in the drums. It gives the operators adequate time to change out the chemistry drum. Having the drum level alarm in place will reduce the likelihood of having a drum empty condition, and it'll help you keep you in specification. Here's an example of the KYZEN CCS and how it's custom mounted on Bosch rails at a particular customer. The CCS on the left controls the concentration in the wash tank, and the CCS on the right controls the concentration in the rinse tank. Again, they're utilizing a chemistry which cleans and protects. Thus, the same chemistry as in the wash and the rinse tank. But going into a little more detail, this is how we provide flow to the probe. Usually, we install a T on the output of the wash pump, usually from a gauge. This allows the probe to monitor the conductivity of the spray, which is applied directly to the parts. So the fluid then flows from the output of this wash pump to the probe. Our probe is flanked by a couple of isolation valves for easy maintenance. You don't have to shut the machine down to clean the probe. Shutting the isolation valves will be good enough. So from the output of the pump, it goes back to the wash tank after it flows past the probe. This shows another example of how flow past the probe is achieved. Up to this point, the main method that KYZEN uses to automatically measure and add chemistry is in the CCS, but we have proved out another concept, and that's using the KYZEN ANALYST. The ANALYST in and of itself measures concentration by detecting the density of the fluid. The probe picture on the left sends a sound wave through the wash bath, and the chemistry concentration changes, so does the density of the fluid, thus the speed changes. The concentration is then displayed on a monitor which comes with the system. When the KYZEN ANALYST is married to a metering pump, you have another method of monitoring and controlling chemistry concentration in a wash bath. The ANALYST and metering pump combo comes with features such as remote process monitoring and a way to track data analytics. So here's a little recap of the concentration control. When you read down this list, become more and more operator independent, but the price also goes up. So you'll have to decide for yourself the cost-benefit analysis of automation versus a warm body on the line taking measurements and adding wash fluids. But this is all for my presentation on automatic process monitoring. I'd like to thank you guys for your time, and I'll turn it over to Sherry.
Thank you, Wayne. If you would like to discuss this topic further, please contact your local KYZEN regional manager or send an email to tech@kaizen.com, and we will have one of our cleaning experts schedule a follow-up with you as soon as possible. Again, we thank you all for joining us today, and we hope to see you again soon. Stay safe, stay healthy, and have a great day.